So it is important that you just don't follow the notes, okay? Please take the books from the library, because many problems are there in at the end of the book, okay? So usually we do those problems. You have to do it. I can do some of them, not all of them, so you can practice yourself, okay? So it's better you take the books or download the books from the internet, okay, and read it. So the first chapter is adsorption. So what is adsorption? It is not absorption. So just keep in mind there are two processes. They are separate unit operation. Like one is absorption, one is adsorption. So both, there is a difference between both of them. Okay. Okay. So what is adsorption? One or more component of gas or liquid adsorb on the surface of a solid adsorbent and separation is accomplished. So this is the definition, okay? So when you are separating liquid or gas, okay, by adsorbing it on a of component of any gas or liquid, like you are separating phenol from water. Phenol is impurity usually in the water, okay? So in wastewater treatment, you need to separate phenol or any other chemical which is dissolved in the water. So this phenol or any other component is an impurity, okay? And you want to remove it from the water. So what you are going to do, you adsorb it on the surface of a solid, okay? On the surface of, so what we say or how we define the adsorption, one or more component of a gas or liquid, okay, adsorb on the surface of a solid adsorbent and separation is accomplished. So here our task is to separate phenol from water. So water is liquid, so one component is phenol from the water. So we are transferring this phenol to a solid surface which get adsorbed on the surface. Inside there are, on the surface of the solid there are small pores, okay? So what happened, this phenol go inside these pores, okay, and stay there, and it's separated from the liquids. So normally carried in fixed bed, and flow is stopped when bed is saturated. So here this happen, okay? This process is carried out in a fixed bed where you have adsorbent, like if you see the picture here, white granules, okay, white particles, these small, these are adsorbent, activated ammonia, okay? So what you fill your container with this, okay, and you pass liquid through this. These solid have small pores on the surface, okay? So your phenol or any other component will be adsorbed in this. So after some time of use, this they get saturated. There is no more space on the surface which take the component from the water. So we say that saturation has reached. This solid is no more capable of separating phenol. So at that stage, what you do? You take out this resin or this adsorbent from the surface. You regenerate it, okay? Regeneration is mean to removing whatever you separated with the help of this phenol. Phenol is still in their pores, so you will remove it by some process, okay, and refresh it, and then you can use it again. So here I am going to read this. Normally carried in fixed bed, and flow is stopped when bed is saturated, okay? Bed regenerated thermally. Thermally mean by heat. So you can heat this or any other way, or by some other method, cycle, okay? There are cycles, absorption cycle, desorption cycle. So you can regenerate and reuse this. So it can be run for years. This adsorbent can be used for many years, okay, by regenerating again and again. So two important thing here, the solid, this white granules. They are called adsorbent. Okay, what is the name? Adsorbent, this solid. And the thing which you are separating, like I give the example phenol separating from water. So phenol is called adsorbate. Okay, so adsorbent and adsorbate. Adsorbent is the solid which is doing the separation. Adsorbate is the component which is separating from what gas stream or liquid stream. Okay, any question up to here? Huh?
How many times can we generate the activated aluminium?
This is not, you can run it for many years, no, 2 years, 3 years, some depend upon the reason, okay? Like in ion exchange process in the boiler section, every industry has boilers, you know, they need steam. So boiler section, before sending the water to the boiler, you must purify the water. You remove all the minerals and these solids from the water. So usually ion exchange process is there. Okay. So we remove ion exchange process is a kind of adsorption process, similar. We will see what is the difference between adsorption and ion exchange, but it is similar. Okay, you can say it is adsorption process. So many years it can run depending upon different type of the life. You cannot predict how much is the life, like human being you cannot predict. Some people die in young age, some people. So depending upon the condition or the maybe run for long time, but or if you're, you know, the component you are separating or the like some acidic quality, then it may, you know, it may run out fast. But the main thing is it how long it gets saturated, because saturation is important for a bed. How long can it give you a service? Okay, because for 2 days, 3 days, for example, it is separating, then it will saturate it, become saturated, no more separation is done. Then you have to remove it from the service and regenerate it. Okay, so this regeneration from the starting up to the regeneration point, this time is important, because if you do more and more regeneration, it means it involve cost. Regeneration also need chemicals or heat. Okay, so what is the difference? Absorption mean something completely mixed in a, like if you put uh, what you can say, if you are separating ammonia from water, ammonia is a gas, okay, and it is completely soluble in water. So if you want to separate ammonia from air and you spray water on it, okay, so what happen? Air is not soluble in water, but ammonia is soluble. So it will be soluble in the water, it gets dissolved in the water, okay, completely dissolved, it become a homogeneous solution. So that is absorption, but in the adsorption, the solid is involved, okay, and the separation take place only on the surface, not inside the body, only on the surface. Okay, there are small pores, so it can be easily recovered. So what are the application in liquid phase? Or so the adsorption process can be used both phases, liquid either to separate gas from a gas, or liquid from liquid, or solid from liquid. So all cases you can use adsorption. Some of the example for the application is here, like removal of organic compounds from water. Okay, like just I give you example phenol. Phenol is an organic compound you are separating from water, so it is one example. Then color impurities from organic compounds. Okay, then various fermentation product from fermental effluents you can separate by separation of paraffin from aromatic and fructose from glucose utilizing zeolite. Zeolite is a Adsorbent. Here it is, the picture is here for adsorbent. Why is zeolite? Okay. The structure is this is the structure shape of this this resin. We usually call it resin. Okay. Okay. Then application in gas phase. Removal of water from hydrocarbon gases. Removal of water from hydrocarbon gases. Then sulfur compound from natural gas. This is very important process on a gas treatment plant where you're taking out gas from the earth. Okay, it contains a lot of sulfur. The gas or the usually the petroleum which comes out from the ground, it contains a lot of sulfur. So this must be removed immediately. So natural gas contains sulfur. It can be removed by adsorption process. Then solvent from air and other gases. Odor from air. So all these application of gas phase, which can be separated with a solid. All these example are for liquid phase, which can be separated by the solid. Okay. Any question here? So next slide. So different type of absorption are there, like physical adsorption, chemical adsorption. Okay. So the type of adsorption are classified as physical and chemical. Physical mean when there is only physical changes involved, no chemical reaction take place between the solid and the thing which is getting absorbed on the surface. Chemical absorption mean some chemical reaction will occur between the solid resin and the thing which you are separating, like phenol and solid, they get chemically reacted. Okay. In physical adsorption, nothing happens. It only goes in the pores and later on separated. So no changes in the resin, no changes in the component which is being separated. So here the gas molecules adhere to the surface of the solid adsorbent as a result of intermolecular attractive forces, van der Waals forces between them. So here the separation only occurs because of van der Waals forces. You know, van der Waals forces are attractive forces. They only attract the solids from the liquid, okay, and keep it attached with their surface. So the only van der Waals forces are there, okay, gas molecule or liquid molecule attached to the surface by just this chemical bonds. Okay, not chemical bond, you can say the forces only. The process is this, all the adsorption processes are exothermic process. Whenever adsorption occurs, there is a heat liberation. Okay, in physical adsorption, the heat evolve is 2 to 20 kilojoule per gram mole. Okay, then the process is reversible. The good thing about physical adsorption is this process is recoverable. Okay, recovery of adsorbent material or adsorbed gas is possible. So whatever goes in the pores, you can recover it easily by increasing the temperature or by lowering the adsorbate concentration or by pressure swing method. So many methods are there. We will see later on what are different methods for regeneration. Okay, so this physical adsorption is recoverable, reversible. Okay, physical adsorption usually directly proportional to the amount of solid surface area. So surface area is very important factor in adsorption. Bigger the surface area, more will be the adsorbent. Smaller the surface area. So for example, if there is a big, let me explain this. Can you see the board?
Yes, we can. Yes.
Okay. So surface area mean, what is the surface area mean? Bigger the surface area, more will be the adsorbent. So if you have a lump, big lump, this is for example resin, okay, adsorbent, okay. For example, this is zeolite, okay. So it is a big lump, so liquid stream passing on this. So only this surface is available, okay. This surface is available for phenol particle to go inside the surface. These are phenol in the liquid. So water stream plus phenol. Phenol is the impurity which you want to transfer here. This is phenol. Okay, so it will go inside the pores. So, but small surface area is available because only one lump is there, big lump of adsorbent. But if I crush this powder or make it a powder form, so this now can be spread to, okay, large area. So whatever stream is passing through it, okay, so it will be so smaller. So a bigger surface area mean you make it a powder in powder form, okay. So it means you don't need big lumps of adsorbent. Smaller the size, better it performance will be. So the physical adsorption depend on the surface area. So it is directly proportional. Adsorbate can be adsorb on a monolayer or number of layers. Okay. What is it meaning? Okay. Can you see the board? Yes. Board.
Yes.
Okay. So it can be adsorbed on a monosurface. Consider one particle of zeolite. One particle. So see, this is one particle. Just imagine it, okay? So you are separating phenol. Again, this example or anything else. So see, this surface is available for adsorbent. This is one side, two sides, like these are the sides on the surface available, okay? So what happened? Phenol, one particle come and take this side. Okay, it will occupy one side. Then second will come, this will occupy one side. Third will come, occupy one side. Like in a room, when you enter in a room, you sit on a chair. So one by one, student comes in the class, they sit on the class until all seats are full. See, the surface will be, no, the surface is full. Okay. So for physical, this is one layer. You can say this is one layer of adsorbent. So second, after this all sides full, then another layer may be formed on the top of this. Okay. So monolayer or multi-layer is possible in physical adsorption. Monolayer mean one layer only. And multi-layer many. So the adsorption rate is generally very rapid. Slide, can you see the slides? Okay. Yes. So now what is physical adsorption? When gas molecule attach to the surface physically by van der Waals forces. Okay, this is one thing. The process is exothermic, heat is liberated, okay, whenever adsorption take place. And how much heat take liberated? 2 to 20 kilojoule per gram mole. Then this process is reversible. You can easily recover adsorbed material from the surface by increasing temperature or lowering concentration or lowering pressure. Then third thing is adsorbate can be adsorbed in a monolayer or multi-layer. Okay. And physical adsorption is directly proportional to surface area. Then adsorption rate is generally quite rapid, very fast. Okay, adsorption take place very fast. This is physical adsorption. Then chemical adsorption. Actually, this is comparison between physical adsorption. So chemical adsorption is result from a chemical interaction between the adsorbate and adsorbent. Okay. So it means whenever something separating from liquid gas stream, it will chemically react with the solid and change the solid, okay, completely. You cannot recover it. This is just one-sided. Once it is reacted, its shape or the properties changed. So therefore form bond, and it make a bond strong like covalent bond or something. Okay, so it form a bond stronger than the physical adsorption. Heat liberated during the chemical adsorption in the range of 20 to 400 kilojoule per gram mole. So it means more heat is evolved than the physical adsorption. It is frequently irreversible. You cannot reverse it. You cannot regenerate the adsorbent. You can put new adsorbent, but that adsorbent will be changed or properties different. On desorption, the chemical nature of the original adsorbate will have undergone a change. So it means you cannot regenerate, or maybe the chemical property is different from the original one. Only a monolayer adsorbate appears on the adsorbing media. It means only monolayer is formed. Here you cannot adsorb multi-layer like in I explain this to you. So once one side is occupied, other cannot be, just one layer will be formed on the surface of one particle. So any question here? Understanding?
Yes.
Clear?
Clear.
Okay.
Yes.
Okay. Just tell me if you don't understand anything, okay? So physical properties of adsorbents. What are the some physical property normally developed for wide range of separations? Okay, they can be used for many applications. Small pellets, beads. Pellet beads mean like this. This is pellets or beads. Okay, small. So granules or granules. So you can say anything, pellet, bead, granules. The size for these is 0.1 millimeter to 12 millimeter in size, and it is used in packed beds. Very porous. The surface is very porous. Okay, they are small. You cannot see the pores with your eyes. Okay, if you want to look the pores, you have to use magnifying glass or microscope. Okay, then you can see the small pores on the surface. Okay, there is a very big surface area available on the pores. You cannot imagine. It is more than 1 gram of adsorbent is like a football ground. It can absorb as many particles like in a football ground. Of a big stadium can occupy the people. So small. This is very strange property of a solid particle. So very porous volume up to 50% of total particle volume. The overall adsorption process consists of three steps, three series of steps like solute diffuse from bulk fluid to a particular exterior surface. Okay, so the first step is diffusion, because in like you're separating water and phenol, so phenol will diffuse through the water and reach to the surface of the adsorbent. Okay, so this is first step. Then solute diffuse on the surface of the solid. So here this is the first step. Look at the picture. So this red color is showing one phenol particle, okay, and this black color is adsorbent. Black color particles are adsorbent. Red color particle is adsorbate. So this as adsorbate reaches to the surface. This is the diffusion process. Okay. Then solute diffuse on the surface of pore. Then second step, it diffuse on the surface of the pore. Look at the picture, second number. Okay. Then third, finally the solute adsorb inside the pores. Then finally it go inside. So this is a pore. This is a hole or ditch, you can say. Okay. So these three steps are for adsorption process. Here it is the picture. All three steps you can see. So step 1, diffusion to adsorbent surface. So this is adsorption. This is solid, adsorbate. These are the spaces inside this solid particle where the phenol particles will go. Okay. So now migration to pores of adsorbent contaminated molecules. The black particles, they will go inside the pores. Monolayer. See the monolayer is formed. See inside only one layer is there. If you look at the walls, only one particle is occupying space. Okay, so this you can say one layer. If there is another layer comes on the surface, then it will be multi-layer adsorption. Clear this? Or no?
Again, Doctor.
I just told you monolayer and multi-layer. You understand that concept? In physical adsorption, multi-layer can be formed. Like one particle, how many spaces available? How many sitting capacity is there? Like in a classroom, 30 capacity is there. When you go in the class, like you are occupying a small particle. Okay, so people sitting on a chairs, 30 chairs are there. After 30 chairs, okay, the you can say it is completely occupied. So similarly, let me explain on this blank paper. Okay. Okay, can you see the blank page?
Yes.
Yes, teacher.
Yes, doctor.
Okay. I just explained to you that this is one particle. Okay. This is adsorbent, zeolite. So you are separating something. So they will reach, first of all, diffusion occur. Phenol is here in the liquid state. So it will diffuse through and reach to the surface. So this is diffusion. Okay, first step. Second step, it will go inside the particle. So it will see inside this particle, there are pores. These are pores inside the particle. Okay, so the phenol will go and form a layer. It will occupy space like this. So one pore is filled. So in physical adsorption, another layer comes on this. Okay, it can have more layers. But in chemical adsorption, only one layer is possible. So this is one layer. See, on the surface, only one layer. This is one layer. Here, one layer. Okay. So you can say on the surface like this. So what is this? This is phenol. Adsorbate. So now see, all sides are completely full. All sides completely full. Okay, so it means what we say at this stage is called saturation. And when it gets saturated, what we do? We regenerate. We regenerate the adsorbent. What we do? We remove this. By heating, we remove this phenol particle. So once it is removed, the site will become fresh like this. Okay, the side, it will again become like this. So in physical adsorption, one layer is possible, in multi-layer possible. After this all sides covered, another layer comes on this like this. Okay. But in chemical adsorption, only one layer is possible. So this is the difference. Now understand? See
Yes,
here, this is one layer. Can you see the arrow? Arrow, can you see on the slide? No, because there is no pen for this. Let me see if there is a pen. No. So you can see here layer, mono layer inside this one molecule is sitting here. Okay.
you mean in the
So this
slide,
is
doctor?
in the slide, yes.
So we are in the
Just,
board now, I think.
okay, okay. Let me share again. So now you understand the meaning of monolayer and multi-layer. Okay. Now, can you see the arrow?
Yes.
So see, I am moving the one layer. See, I am moving the arrow on the layer. See, this is one layer. See, inside. This is one layer. Okay, still some space is available. See, empty spaces between, so more particles can come. Okay, these are sites, active sites on the surface. Okay, so just look at and try. So 10 o'clock, I think enough for today. We will continue next week, because just read this first, because if I give you more, maybe you'll get confused. Okay.
Okay.
Okay, wait. Attendance. Give me your IDs. Wait, I will call. Three 6000001 present.
Yes.
Okay. 3710381.
Yes, teacher, present.
3710461.
Yes, yes, teacher, present.
Okay. 3710836.
Yes, yes.
3711008.
Yes.
3711062.
Yes, doctor.
3711208.
Yes, yes, present.
3720067. 20067.
Yes, yes, teacher.
Okay. 3720463. 463. Okay. 3720911.
Yes.
Okay. 381011. 381011. 3810121.
Yes, teacher.
3810131.
Yes, doctor. Here.
3810133.
Yes.
3810144. 3810151.
Yes.
3810292. 3810403. 3810534.
Yes, yes,
3810534.
yes, yes, teacher, yes.
Okay. 3810630.
Yes, present.
Okay. Okay. Thank you, everybody.
Doctor,
Any question you can ask. Okay.
my my number.
Teacher, my
Eh,
number.
Which one?
Teacher, I didn't.
Tell me. Tell
I
me.
did.
It's
655.
خلاص يروح.
3810655.
Yes, present.
Present. 3810739.
No, it's 36000605.
605. Say, okay. 3810655 is there. 3810739 is also there. 103739 present.
Teacher, my number 3600995.
Yes, yes, present. Okay.
Did you
Okay, thank you.
finally?
Yeah.
And don't forget
What?
to close the recording because it will be continued.
Okay, okay, wait.
Hello, can you hear me, teacher?